In today's video, we will discuss about diesel cycle, the operation cycle behind diesel engines, which powers trucks, buses, and heavy-duty equipment. We will break down this cycle in following aspects. The animated video of the working of diesel cycle means we are going to see the four strokes, that is intake stroke, compression stroke, power stroke, and the exhaust stroke. Working principle of four-stroke diesel engine. Working principle of four-stroke diesel engine is as similar as petrol engine, but the only difference is the spark plug. Now we are going to see the PV graph and the TS graph. In this graph, we will see that how the combustion processes and the how isentropic compression, constant pressure heat addition, and isentropic expansion, and the constant volume heat rejection. Now first we will see the intake stroke. In intake stroke, inlet valve opens and the air enters the piston. Then piston moves from BDC to TDC. In compression stroke, inlet valve closes and piston moves from BDC to TDC and the pressure and temperature increases. It increases at the high level. Then the diesel fuel is sprayed due to the high pressure and temperature from the fuel injector. At the end of compression stroke, combustion of the fuel happens. Then the most important stroke is power stroke. Power stroke happens between TDC to BDC. Pressure and temperature increases and piston comes to its original position at BDC. And at the end of the power stroke, exhaust valve opens and the final exhaust stroke is going to happen here. Piston again moves from the BDC to TDC.
Is the 5 cycle. In that our topic is the diesel cycle. We are seeing in the diesel cycle there is the 4 processes. In that the isentropic compression, isobaric heat addition, isentropic expansion and isocooling expansion. We are going step by step. In that the first process is the isentropic compression. When we are seeing the piston is moving upward. In that the PV diagram shows the 1 to 2 process. Ratio of value V1 and V2 as compression ratio. When we are talking about the second process, there is the isobaric heat addition process. When piston is going to TDC to BDC. In that PV diagram shows the 2 to 3 process. Ratio of volume V2 and V3. We are in the process number 3, the isentropic expansion. Piston will going TDC to BDC to TDC. In that, PV diagram shows the 3 to 4. When we were talking about the process for the isochoric expansion, they're characterized by the exhaust and intake stroke.
The CFC formula for a diesel cycle. This is the PV diagram of a diesel cycle. So, here the Q1 is equal to Q2 minus Q3 is equal to MCP T2 minus T3. And here Q2 is equal to Q2 is equal to Q4 minus Q1 and MCT T4 minus T1. So the efficiency formula is 1 minus Q2 upon Q1. So efficiency formula is coming 1 minus T4 minus T1 divided by T3 minus T2.
Discuss about the key differences between the diesel cycle and Otto cycle. When you are talking about the fuel injection, in diesel cycle, fuel injects after the compression, and in Otto cycle, before compression, the fuel injection process happens. When you are talking about ignition, in diesel cycle, compression ignition is there. That's why the diesel cycle is known as self-ignition cycle. Then in Otto cycle, the spark ignition is happen. The best example of Otto cycle is petrol engine. About compression ratio, the diesel cycle having higher compression ratio than Otto cycle. And when you're talking about efficiency, diesel engine is most efficient engine than the Otto cycle. The Otto cycle engine gives more work output, but there is a difference between work output and the efficiency. That's why the diesel engine has higher efficiency.
So we are talking about the advantages of diesel engine. There are the three advantages. The first one is the fuel efficiency. In that, the higher the compression ratio in the diesel cycle, the result is the more efficient. And in the we are talking about the second point. There is the durability. In that, the durability, the diesel engines are built with the reverse combustion component designed to withstand the high compression ratio. We are talking about the torque. The third point, we are talking about the torque, the higher compression and the controlled burning fuel in the diesel engines.